The Taxon Archive Lab Library, or TAL, is a database and teaching tool for landscape materials. The database is open and extendable to capture the ever-varied materials that make up Hong Kong's constructed terrains.
This video introduces the archive, the body of material samples and process that regulates how we collect, store, and digitize our resources.
Types of data in the archive include text descriptions and records of physical or chemical properties, photographs or other graphic representations of a material, and specifications related to the shape, makeup, form, or procurement of a given sample. Whereas the decay and aging of the collections is not a desirable outcome in most libraries, our archive attempts to index and record time and weather-based changes to sampled materials of living, weathering, and degrading substances.
Aging conveys important information about the temporal conditions and the stability of various materials. Some samples in the library, such as our soil series, include geotagged references to samples remaining in situ, allowing us to reference the unextracted base material for comparison over time between the lab and the site. This characteristic of the archive allows students to compare material behavior in different environments and to understand the role of weathering and other physical and chemical processes. It also communicates how these time-based processes are inextricably tied to place.
Like other material archives, we record common categories such as ceramics, metals, or polymers. But by linking categories and process, we emphasize how materials are sourced, extracted, and produced. We have developed a material wheel that structures the varied modes of input as classified through the taxonomy. A sample can be mapped along the radial segments that index state and condition. Radial mappings can be adjusted as qualities of a specific sample vary or are modified through experimentation.
By encompassing the range of materials that are encountered in landscape practice, the TAL database must also consider a range of material input tracks. These tracks help to focus a given material entry in consideration of its mode of collection, its application or manipulation, its performance or appearance. These tracks allow the library to balance intervention with investigation.
Site and source-driven library entries record a material-specific condition found during extraction or information about a material's origin, such as the impact by climate, the ground conditions, and topography. Classification or attribute-driven entries record information about a material's specific form, physical or chemical properties, helping to identify and respond to issues of use and performance. Process or observation-driven entries record information accessible through our users' physical or sensorial interaction with the sample. Material qualities are determined by tactile or visual observations or by the way the sample has been processed. These process-driven entries are an important part of the extendability of this library. Whether handcrafted or manipulated using digital technologies, the variables encountered in fabrication are recorded to facilitate the rigors of materially oriented design.
The structure of our archive balances quantitative parameters, such as chemical, physical, and geographic entries, with tactile and observational qualities that inform design practice. The library, under that structural framework, is not understood as a terminus, but as an open-ended record incorporating digital and physical collections. Library users benefit from creating and manipulating entries in the database. Each material sample can have multiple snapshots of its condition recorded. Users can observe a sample's natural aging over time or actively manipulate it through iterative processing in the lab.